Hello students, welcome to TSA's Tutorial Center, where we make complicated topics simplest to understand. So if you're in grade 12 and you've been having challenges lately, then make sure you subscribe to this channel so that whenever I post a tutorial, you can access it for free. In this tutorial, we'll talk about gas laws. And still some students have been saying that gas laws, they're very difficult to understand. Now, I don't want you to have that mindset. I want you to listen to understand and not to complain. And make sure you watch until the end where we're going to solve the same questions that you've been saying now. These questions, they are complicated. What am I going to do here? We're going to solve the same questions together from the exam paper. So let's continue. Let's dive into it. Okay, so the question here is, what are gas laws? What are they? Because you can't just be talking about everything minus talking about gas laws itself. So let's define what gas laws are. This is the study, just going to be studying. This is the study of the behavior in what else? Response. Response of gases. We're just going to be talking about gases. So we'll be studying the behavior and response of gases to what exactly? So there will be three things that we're going to focus on, and that is pressure, volume, and temperature. Okay, so what are we saying? We're saying gas laws. This is the study of the behavior response of gases to what? Pressure, volume, and what? Temperature. Now, in physics, if you want to become very good, make sure you give your time to understand what pressure is, what volume is, and what temperature is. So let's talk about pressure. What is pressure? Pressure. How can you define pressure? Some of you can say this is the current situation in my relationship. No. When talking about pressure, pressure is just a force per unit, area. Do you remember when we're talking about density? We used to say density is equal to mass over volume. In the definition, we were saying this is mass per unit volume. Okay, so the same definition, that's what we're going to use here. We're saying this is force per unit area. So we can equate pressure being equal to force divided by the water area. Now, the same pressure, does it have units? Yes, it's supposed to. Because looking at this guy, force, it is measured in what? Newtons. And the area is measured in square meters. When you divide, you're going to have Newton square per square meter. And this is equivalent to what? Pascal. So when they ask you to say what are the SI unit of pressure, just Pascal. Very simple. Then we have volume here. Let's talk about volume a little bit. Volume. What is volume? The sound of the speaker, eh? This is the sound of the speaker. Okay, so when talking about volume is actually the amount of space an object occupies. Amount of space an object occupies. Now we're talking about gases, so we can say this is the amount of space a gas occupies. So between this gas and this one, which one do you think occupies more space? We can definitely say it is this one because it's covering a lot of space. Now, when talking about the same volume, the units are going to be maybe centimeter cube. We're going to be putting a 3 to the units. Square, nope, we're going to be using the cube. So this is meters cube. We can also have centimeters cube. Okay, so for pressure and volume in this syllabus, no need of converting the pressure, no need of converting the volume. But when it comes to temperature, we're definitely going to be converting. Okay, so let's talk about the same temperature. What is temperature? The bipolo ba bantu ba monaka ba promoter. This is how you're supposed to be studying physics. You understand the factors that is causing the same response of the gases. What is temperature? This is how hot or cold a substance is. Now we're talking about gases, so we can say this is how hot or cold a gas is. Now talking about the same thing, what are the SI units of temperature? So some people can say degrees Celsius because you've been talking about degrees Celsius whenever you were in when you were in grade 9. But those, they are not the SI unit of temperature. Have you ever heard of Kelvin? The same Kelvin. Kaya who he is to you, but to me, they are the SI unit of temperature. Kelvin. SI units. We are saying that is Kelvin, denoted as capital letter K. Okay, so in a situation whereby you've been given the temperature being in degrees Celsius, make sure you convert it to kelvins. Now, what are you going to do? Know that temperature in Kelvin is given by temperature in degrees Celsius plus 273. So, in a case you've been given the temperature in degrees Celsius, let's say it is 5 degrees, and they tell you to convert this guy to kelvins. You're just going to substitute 5 where you're seeing temperature in degrees Celsius, and in this case we'll have 5 plus 273. If you can't do this using your mind, then you can use a calculator, but I'm sure this number plus 5, that is 278. So far we have talked about the terms that are used, and make sure you understand these terms because we'll be talking about pressure and volume and temperature until we finish talking about gas laws. Now, what else are we supposed to know? Behavior and response of the same gases. Let's talk about the behavior and response because we are saying gas laws, this is the study of behavior and response. Now, let's talk about the same behavior and response. Okay, so when it's heated, what happens? Suppose you have 2 particles, and let me say 5 particles of a gas. Then, think of these particles and you, like you and your friends, but maybe sitting somewhere. Then at the place you are sitting, I just come, then I put fire. What do you think will start happening? You guys will start moving, and the water is going to be, the more faster you're going to be moving. So you start moving, when you move. Maybe you see your friend that side, you yourself that side. Uyoko, kambyuko kona kunganda. Even sleeping. The bad kolo ba bantu ba monaka ba promoter. What has happened here? The volume the gas was occupying has now increased. Now, they're going to ask you a question to say, when you heat a gas, why is it that its volume increases? We can see the volume we said is the amount of space. So this one, the volume is greater compared to this one, because this one is covering just a small space. Now look at this. What is going to happen is, when you heat the gas, the particles are going to gain heat energy. Okay, so the first thing is they will gain heat energy. After that, this heat energy is going to be converted to kinetic energy. Kinetic energy. Now, what is kinetic energy, if I may ask? This is the energy of a particle in motion. The energy in what? Motion. So these particles will now start to move. Papa, the same way you were running after Nami Ocha will start moving. When they move, they are going to expand. And when they do expand, then we can say, hence, the volume increases. Very simple. Okay, so what are we saying? We're saying when a gas is heated, it gains heat energy, which is then converted to what? Kinetic energy, causing the particles to start moving and expand. Hence, the volume is going to do what? Increase. Very simple, and they are going to be asking you these questions. What about a case, instead of heating it up, we are cooling it? So suppose we have these guys, then we'll start cooling them out. And cool down, what is going to happen? Instead of gaining the heat energy, they're going to do what? Lose the heat energy. When they lose the heat energy, it causes the kinetic energy to do what? To decrease. And when the kinetic energy decreases, the particles will now contract. Not construct, but contract. Contract. And hence, the volume is going to do what? Decrease. So it's just the opposite. When you know what happens when it's heated up, then make sure when talking about when it's cooled, you just write it as the opposite. Very simple. Now, one last thing. The relationship that is there between pressure and volume. This question counts. Okay, so I hope so far so good. Now let's talk about the relationship that is there between pressure and volume. Okay, so take note. Pressure and volume, they are inversely proportional. They are inversely proportional, which means when you increase the pressure, volume is going to do what? Decrease. When you increase the volume, then pressure is supposed to do what? Decrease. So you may think of your relationship. When your guy gives you money, the money for the guy, it reduces, but the girl, it increases. You may think of it in that way. But the bab could be bantu bamanaka ba promoter. they can ask you the question to say, why is it that when you decrease the volume, the pressure increases? This question is most commonly in the exam. Now let's talk about it. Okay, so suppose this is a balloon. Yes, not what you think, a balloon, just a normal balloon, nothing else. A balloon, and we're tying it that side. Then there is particles of a gas in there. And just put 4, okay, 5. These particles, the volume is very much greater for the gases to move around freely. They will be moving, pa 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 pa. Then I come here and I start reducing the volume. I start reducing the volume. The volume start to become small. They say the volume now, the balloon becomes something like this. These particles will have less space to move around, and they will be striking the wall of the container more often. Hence, the pressure is going to do what? Increase. There are some cases whereby you're trying to reduce the volume of a balloon and it end up bursting. It means the particles were eating the wall very much. Pum 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 pum. So as they were doing so, it causes the balloon to just burst. Okay, now look, the question is why is it that when you decrease the pressure, when you decrease the volume, pressure increases? This is because the particles will have less space to move around. Now don't just say this, it is 2 marks. So that is 1 mark. So you say the particles will have less space to move around and they will be striking the wall of the container more often, causing pressure to do what? Increase. The particles will have less space to move around and they will be striking or colliding with the wall of the container more often, causing pressure to do what? Increase. Okay, so doing so, then you're good, safe and sound. Okay, so we have talked about the behavior. Now let's talk about the same gas laws. So talking about gas laws, we're going to be using PVT. PVT has been used at universities, and a lot of grade 12s you're using it as well. Some they have already completed and now they are at the universities of their choice, and they use this guy, PVT, where P is pressure, V is volume, T is temperature. So I'll show you the same strategy that I came up with to remember all the laws. So there is Boyle's law, there is also Charles' law, and there is also Gay LUSAC law, which is commonly known as pressure law. And lastly, there is the general equation. Okay, so what I want you to take note is this. When you have two quantities, they are dividing. And I ask you to say, are they inversely or directly proportional? I want you to know that when you are dividing two quantities, that is directly proportional. So remember, D goes with D. Then if dividing goes with directly proportional, then multiplying is going to be inversely proportional. I want you to keep this in mind because we're going to be using it. And the next thing is take note. The temperature is always divided into the quantities remains with. Temperature is always divided into the quantity it remains with. This is very much important if you're going to be using PVT to remember all the laws. Let's talk about Boyle's law. Boyle's law from PVT just got PV. Then Charles just got VT. And we said temperature is always divided into the quantity T remains with. So it's going to be V divided by the temperature. Then pressure low, get LUSAC low, got pressure divided by the temperature. Then this guy got the entire thing, PVT. But keep in mind, temperature is always divided into the quantities. Bam. So just doing this, I can help now to come up with the laws. I'm not going to remember the definition or the statements. No, I'll be just focusing on what he got, making school very much simple. When talking about Boyle's law, we said when two quantities they are multiplying, this is P times volume. It means they are inversely proportional. So what are you going to see? You're going to see pressure is inversely proportional to what? Volume. At constant, what's missing here? Temperature is not here. So at constant temperature. Now, how are you going to be starting? You should always start as, since you're talking about gases, so it should be for a fixed mass of a gas. For a fixed mass of a gas, pressure is inversely proportional to what? Volume at constant temperature. Very simple. Now looking at Charles' law, we're going to do the same thing again. We know they are dividing, so this is directly proportional. Again, you start the same thing for a fixed mass of a gas. Volume is directly proportional to what? Temperature. At constant, what's missing here? Pressure is not there. So at constant pressure, for a fixed mass of a gas, volume is directly proportional to temperature at constant pressure. This one, I'm sure you can even state this one. For a fixed mass of a gas, pressure is directly proportional to temperature at constant volume. Very simple. So just remember what these guys were getting. Now what about this one? This states that for a fixed mass of a gas, the product, meaning the multiplication, the product of pressure and volume divided by the temperature. Since there is nothing missing here, you're just going to see is constant. Is constant. For a fixed mass of a gas, pressure, the product of pressure in volume divided by the temperature is constant. By doing so, you know how to state. In these things we've talked about now, we can solve exam questions like no man's business. We are ready for it. Okay, so make sure you know how to state Boyle's law, make sure you know how to state Charles' law, make sure you know how to state LUSAC law, but make sure you know what they were getting, and it will be very much simple for you to do so. The Bab kono babantu ba monaka ba promoter. Let's now dive into questions. Okay, so this question came in 2022. Just a multiple choice, but one mark in an exam is very much important for you to get a distinction. And we're praying that you'll get distinctions like always. People have been getting distinctions. Okay, so if 1200 cubic centimeter of an ideal gas is heated at constant pressure from 27 degrees Celsius to 127 degrees Celsius, what will be its final volume? Okay, so I don't want you to be thinking between Boyle's law, you want to come up with a formula. Ish. This formula, which one are you going to use? Even for Charles' law. This is for Charles' law. The same thing they are getting, just put two in once, then put an equal sign. Then there is also LUSAC law, which is the pressure law, which is the pressure law. Okay, so these are the formula. This is for Boyle's, this is for Charles, and this is for the pressure law. Now look, I don't want you to be thinking about which one am I going to use among the three, or the last one, which is P V1, then this side, I just put twos. I don't want you to be thinking about this. What you're going to be thinking about is just PVT. Now you go back to the question. If 1200 cubic centimeter of an ideal gas is heated at constant pressure. That's the point that I'm looking for. At constant pressure. When we're talking about boils, we said it just called PV, and this is the formula. So the definition, when we stated, it was at constant temperature. So we cancelled T from PVT. So there is nothing as temperature here. So whenever we hear the word as at constant pressure, you are going to go back to PVT, then cancel the pressure. Okay, so let's cancel pressure, which means the formula I'm going to use is just V and T. And we say temperature should always be divided into the quantity it remains with. Now, looking at the temperature we have, it is in 1 degrees Celsius, and we're supposed to convert to kelvins. What did we say? We said you're supposed to be adding 273. So even for T2, we're going to add 273. So for the first one, you should get 300. For the next one, you should get 400. So what are you looking for? What will be its final volume? So it's supposed to make V2 the subject. Now you can substitute the things that you've been given. What is V1? It is this one. And since it's been heated up, then definitely the volume should increase. So this is not the answer, because it's less than this guy. The volume is supposed to increase. Let's substitute. Temperature number 1, 300. This is equal to V2 and divided by the temperature 2, that is 400. Okay, so whenever you have two quantities occupying the same positions, then there is an equal sign. The zeros can cancel. But anyway, let's just go direct. So you're going to have 300 V2, because some people will still get confused, and multiplied by 1200 times 400. Then you're going to divide by 300, even this side by 300. The zeros cancel, so should you understand what I was saying. So V2 should be equal to 3 into this guy, that is 4. So we're going to have 400. Use a calculator. This guy times this one, we're going to have 1600 cubic centimeter. So I never converted the volume. I only converted the temperature that I've been given. But be careful. If you don't convert, you still get an answer. It's this one here, but it's wrong. Okay, and you come out from the exam, you're even more daring, I've written the questions correct, but it's wrong. Okay, let's look at the next example that we have. Let's be fast. Figure, this guy shows a cylinder containing a gas of volume 5 cubic centimeter at a constant or at a pressure of 100 kilopascal. The piston is pushed to half the original volume at the same temperature as shown. Okay, so this is the piston, then it was pushed half to its original volume. So if the initial volume is at the start, if the initial volume is 5 cubic centimeter, then they see they pushed the piston half of 5 cubic centimeter, then the final is going to be what? Common sense, if it was 10 here, then you push it half of 10. It's going to be 5, not so. Yes, so we're going to do the same thing. So 5, the half of 5 is what? 2.5 cubic centimeter. Now the question is saying at the same temperature. So what formula are we going to use? At the same temperature, you're just going to come to PVT, then cancel where temperature is. So the formula you're going to use is P1 V1 is equal to P2 V2. You're only going to be dividing when you have temperature. Okay, so this is the formula that I will use. Question number 1, state Boyle's law. You can fail to state this one. Boyle's law, just quote water, PV. And we know that there is nothing as dividing here. We don't have temperature. So to state this guy, we're going to say for a fixed mass of a gas, pressure is inversely proportional to volume at constant temperature. Okay, then the last question, calculate the gas pressure in the cylinder in figure B42, which is this one here. So if you've been given the pressure in the first one, then they ask you to say what is the pressure in this cylinder. So you're definitely going to do a substitution. We can see that pressure is in kilopascal. You're going to substitute 100 for pressure. So whereas I'm saying P1, I'm substituting 100 times volume 1. The first one, that is 5, is equal to. Okay, so here we're looking for pressure 2. Then we know that volume 2 is 2.5. So going to divide 2.5 even this side by 2.5. So this guy into this guy is 2 times. Then 2 times 100 and should give 200. So since it was in kilopascal, so even this side you put kilopascal. You're done. This is what people do who get distinctions. This is what we do. So just make sure you're following. Getting a distinction is very, very much easier than failing, my dear. Okay, now let's look at the last question. Mind you, don't focus on the time, don't focus on the missed calls, don't focus on the messages. You guys, you are very, very, very evil. You can even read my text. But don't even check my battery. And let me just okay. Alright. So the question is saying figure B41 shows a glass syringe with a sealed tip containing a gas at an initial pressure of 360 Pascal placed in hot water machine. After a few minutes, the piston in the syringe moves up. So there was a gas here. Then after some minutes, the piston started moving up. Then it reached this far. The first question is saying, use the kinetic theory, explain why the piston in the syringe moved upwards when the syringe was placed in hot water. The same thing we've been talking about. So there was a gas in here. Then since the H2O, which was this side, was hot, it started heating up the gas. And what did we see? We said the particles are going to do what? They're going to gain heat energy. Then the same heat energy is going to be converted to what? Kinetic energy, causing the particles to start moving. Because kinetic energy is energy in what? Motion. So when they start moving, they will expand. And the volume will increase, causing the piston to move upward. So just saying, the particles gains heat energy, which is converted to kinetic energy, causing the particles to start moving and expand. This causes volume to do what? Increase. The piston will move upward. Very simple. That is the kinetic theory of gases. Now what about B? The piston is pushed downwards at a volume of 220 cubic centimeter. So at first, what is the volume here? So on top there, the volume is 60 cubic centimeter. Then it was pushed to 20. So we're going to say volume 2 is now 20 cubic centimeter. In terms of kinetic theory, explain why the pressure of the gas in the syringe increases. Same thing we talked about, guys. We said when you decrease the volume, the pressure is going to increase. Now what did we say in detail? We said the particles will have less space to move around and they will be striking the wall of the container more often, causing pressure to do what? Increase. The same thing. So make sure you understand the introduction. Then I start applying it in the papers. Make sure you understand what I taught at first. Make sense of it. Then the last question, calculate the pressure of the gas in the syringe. So to answer the last question, you're supposed to use PVT. Calculate the pressure. Okay, so pressure, what was kept constant? Temperature was kept constant. So I'm going to cancel the temperature. So what am I going to use? Boyle's law again. Just going to put ones this side and this side, put twos. Then looking for pressure, which is P2. So just start substituting. I know that at first the pressure is 360 multiplied by what was the volume? Just there, it is 60. That is volume 1 is equal to. We're looking for this guy. And this guy we've been given that it is 20. I'm just going to divide this side. So this one and this one. 20 into 60, that is 3 times. 3 times 360. So you should get 1080 So here is just Pascal. So no need of saying kilopascal. Just put the same pressure units you've been given. So this is how simple the questions are in the exam. Very interesting and straight to the point. Okay, so make sure you do subscribe. Make sure to comment, to like as well, to keep the page alive. The Babkalo Babanti Bamuna Kaba promoter. Thank you for watching.